let's go ahead and light this candle. So thanks everybody for coming out. I am Sam McDavid, and I'm going to talk to you about lessons learned with working with Put Dynamic Repo today. There was a lot of messing around and finding out, and running through sharp edges and stuff. So it's definitely been a journey. So today, what I'm going to talk about is I'm going to take y'all through the entire journey of what we did, starting with what we do at Validere, the requirements that we received, the research spike that we needed to do, all the infrastructure changes that we needed to get to, the whole 9 yards. So we're going to talk through all of it. But at the end, if you have any questions, definitely come and find me, because every time I've practiced this, I've used all of my time. But let's go ahead and get started with the context. So y'all may believe this, my family still doesn't believe this, but I am a software engineer. And particularly, I'm a lead software engineer at Validere, and we are a QMRV SaaS platform. For those unfamiliar with the acronym here, that's software as a service. Actually, it's a quantification, measurement, reporting, and verification, and we do that for carbon dioxide and methane emissions to help companies track their emissions, so that way they can either fix some problems on their sites or just try to reduce their emissions. And since we have multiple customers, we've also built a multi-tenant platform. So we have customer ID like all over the place, just like you would expect, having worked on SaaS platforms before. We also have multiple services that we're working with and building out. And each of these has their own Postgres database. And we keep that in isolation just because we don't want to clobber each service's data. And also, each of those services is deployed in its own AWS account. It's not super important, it'll come up later, but everything's deployed in its own AWS account, so we have to do a lot of hoops before AWS RAM came out in order to make sure that we weren't getting charged for all kinds of extra network traffic. And then what we do with this emissions data is we have to generate line items in a report, and we do that through a gen server because we need to keep track of the state, so in that way we're not constantly hammering our time series database for measurements. And then finally, I'm giving this talk primarily just to, I know I'm preaching to the choir here, y'all all love Elixir, but my boss and other managers that I work with have a more enterprise Java or .NET background. They were kind of skeptical about our approach to this because for them, they just use an annotation for everything, magic everywhere. But let's go ahead and shift gears and talk about the requirements that we received. And where we ended up was the product team came to us, and ultimately they said, we need to be able to encrypt each customer's data with their own encryption key. So then that way we're not leaking any data anywhere. They're very security conscious. They want to keep this data private. They also wanted to have their own database, which some of these customers are very large. So we decided to give them their own hardware just so that way they didn't DDoS any of our other customers that were on the multi-tenant database. But where they started was this customer in particular wanted to bring their own database. They didn't want us to have any access to the data at all, and they wanted to be able to control who could see the data, but also they didn't want to accidentally leak data to other customers because of a bug or something like that. And then also we needed to be able to make this so that way we could easily churn a customer. We don't want that to happen, but if you fail to plan, you plan to fail. So we wanted to go ahead and make sure that we handled that contingency. So with that, this was all of the information that we were given. And then we started diving into the research spike to figure out what it is that we needed to do and just starting with our options, trying to figure out what we can do. And one of the first options that we came up with was, since we're deploying all of the services to their own AWS account, what if we just give the customers that want this their own AWS account? That way everything's completely separate. But the issue with that is that we're a very small team, and in managing that separate infrastructure, that's definitely more overhead for us, and that takes away one of our developers of a 3-person team to maintain infrastructure. So we ultimately decided against this, just so that way we could keep producing value. Another option that we looked at was prefixes. I haven't used prefixes in Ecto before, but I'm a big fan of blog-driven development. So we went and looked at a blog, and it looked like we needed to have the database on the same hardware, so then that way you're just changing the prefix. So that made that not an option. So then we wanted to know, just, is this possible? We have an option that would work that we didn't want to do, and an option that didn't work, so it was a non-option. So we started looking online, and Sasha Urich to the rescue. He's replied to somebody who's had this same problem. Don't try to read all this. The important part is that he says, use put dynamic repo, so we had at least an idea of what to do now. And they also wrapped it in their own tenant module, so then that way they could look up the connection that they needed and be able to connect to the correct database, which is super helpful, and we definitely leveraged that idea. The next thing is, once we found that out, we immediately went to the documentation. I love the documentation in Elixir. Just everybody does a good job with documentation. It's so easy to read. The main thing here was we wanted to get an idea of, like, how do they recommend that we use this? And it looks like, you can supply a name or just reference a repo by atom. And then once we had that, we're going to go back to blog-driven development. We decided to go and look, and we found a blog. This wasn't exactly what we were doing, but it gave us enough so that way we could at least infer what would be going on and kind of what we could expect to see. And at this point in time, we had the bare minimum amount of information to be able to move forward. We knew that there was a possibility that we could do it. We also knew that there was a possibility for failure and being able to mess everything up. So we decided to be like Leroy Jenkins and just run in and do it. At least then we could, if it went bad, we were going to build everything in just a small enough and isolated way that we could just yank it out and be able to just get it done. So the first lesson here, Nike, just do it. They didn't pay, so I wasn't supposed to say, but you just got to dive in and get it done. There is no plan that's going to be more valuable than working software. So you always want to try to get something working, get it into someone else's hands, get feedback. So just do it. So with that plan in place, we started looking into the infrastructure, and our infrastructure we manage in Terraform. So that was very nice because we already have a module that we've defined in Terraform for defining our database, the KMS key for that, the encryption key for that, and also all of the networking and everything. So we wrapped this in another module and supplied a dictionary of all of the tenants that we needed. And then inside of that, that handles creating the database for each tenant, but it also puts the connection credentials into Secrets Manager for us, which we can then read as environment variables because we're using ECS. So that's really easy to get in. And this kind of met the baseline requirements that we were given, in that we needed customer-specific hardware and we couldn't reuse KMS keys. So with that, we had a plan for what we were going to do in our production-like environment. So now we needed to figure out how we were going to handle this locally in our own local development, because we need to be able to test it out before we deploy it. So what we did was, in setting up our local environment, you guessed it, we used Docker containers, specifically Docker Compose, and just used multiple ports for that. So that way we could run multiple databases locally and be able to test it out. We also created a volume that we put in the root of the code repository. So then that way, if our QA person ran anything locally and came up with a unique scenario, they could just tar it or zip it and send it to us, and then we could investigate it further. So then that way we're doing an apples to apples comparison. So that was really nice. But that's where things kind of got tricky again, because when you start connecting, you configure it in your runtime.x's, and at that point you supply the credentials, you state the size of the connection pool that you want, but you don't do that for multiple databases. So what we did was, since we're using mixed releases, we went in and decided that we were going to leverage this and expand upon it. So then that way we could read the environment variables in from Secrets Manager. We're going to manually create a pool for each database. So then that way we can then use put dynamic repo with the wrapper. So that way we can go ahead and connect. And the takeaway here is that since you're diverging from what comes out of the box, you now have to worry about this yourself. It may not be a conscious decision that you're making, but it's definitely a consequence of your decision to go down this path. So it's not too terribly bad. You just have to worry about it. But also, once we kind of figured out what we wanted to do there and got the connection pool set up, we wanted to know, like, okay, we're connected, but how do we get the schema there? And the answer here is that you need to create your own custom mix tasks for rollback and migrate. So then that way you can use those. And thankfully, the release module already has most of this built out. So you can just leverage that in your custom mix tasks. And especially since we had already modified it for the connection pool, we were already ready to do that. And then for production, just like before, we were handling that in the application module on application start. And it worked really well. And again, this is really a reinforcement of the previous lesson, but you have to define your own custom mix tasks. You don't get anything for free that you're used to getting for free. So you do have to look at that. So once we figured that out, we had to figure out how are we going to integrate this in our code. We knew that we wanted to follow Sasha's advice for managing that, just creating our own module, so in that way we can look up a connection in the connection pool that we need. But I'm also a big fan of trying to create a flow chart just of how data moves through the system, just because I'm a visual person. It gives me something visually to look at. So then that way it was really easy to point and say, this is where we need to do it. So we created the module based on Sasha's recommendation. We also created an async version of that same task, so that way if we needed to run something asynchronously, we could handle that as well. And then referring to that flowchart, we were able to say, okay, it makes the most sense to put it here in front of our REST API as a plug. So after our authentication and authorization plugs, we then set the repository, the database that we want to connect to. This was very important because we know that Phoenix is not our application, or our context is where our business logic goes. And yes, this is a business requirement, but in this case, it doesn't make sense to put this in your contexts because then you have to do it for every single function. And the development overhead of that gets really high because then you have to remember to do that for every single new feature that you ship. But then you also have to make sure that as you write every new function, you need to test that to make sure that you're actually doing it, so that way you don't have a regression. So the lesson learned here is it isn't rocket science. Don't overthink it. You definitely want to get something out there, and you want to keep it simple. So don't over-engineer it. Keep it easy. Keep it light. If you can't explain it, it's probably not the right way to go. You want it to be very easily understood because you need to make sure that your team is aligned. So once we got that together, we started testing, and what we noticed immediately was that our data is getting committed to the database in test, but only for the single tenant that we're testing with. And ultimately, that happened because we were taking the sandbox connection for granted. You know, if you've been doing Phoenix and Ecto for a while, it's just there. You don't have to think about it too terribly much. Just don't run your tests in async, and everything usually works out fine. But it makes sense looking back, because hindsight's 2020, that was happening because when you call put dynamic repo, it ends the current transaction that's open, it checks out a new connection, it starts a new transaction, and because it's configured to connect to the database, it does exactly what you asked it to. So contrary to popular belief, like, computers aren't very smart. They do exactly what you tell them to. So that did cause a problem. It did get the data committed to the database. And the main thing here is that, you know, obvious things aren't obvious until it just smacks you in the face. You know, don't be scared to learn something new. It's not going to be too bad. But this is kind of in the same vein of common knowledge isn't very common. You don't really think about it until you get in there, you try it, and then you find out. Which, you know, with a lot of this, especially with the minimum amount of research that we did, none of this was covered. So this was all like new sharp edges to us. So we've got data committing during test, taking the same approach that we did when we started the research spike. We wanted to look into our options and see what we could do. One of the options that we came up with was creating a connection pool of sandbox connections just for the test environment. And ultimately, we decided against this because we couldn't really agree on how we would start doing that, where we would put it, or even how we would necessarily explain it to our product team. And if we couldn't explain it to them, it wasn't worth doing. It wasn't simple enough. So it just wasn't a good solution for us. So we went to the complete opposite side of the spectrum. And the easiest thing to explain was we can just clean up the data manually with each test. But for the same reason that we didn't put all of this into our business logic, we also chose not to do that with tests, because then every time you write a test, you then have to clean up the data if you're hitting your database. So that increases your maintenance overhead, and ultimately you start working on things that don't provide value to your customers. So that was also a no-go. What we ended up actually doing was updating the test alias. It's already doing an Ecto reset. We just made sure that we started using our custom Ecto reset that we did, so that way we wouldn't blow up anyone's local environment. So if you can throw a brick at it and solve the problem, do that. Don't over-engineer it. Just get something done. This was a 3-minute change with a 2-minute coffee break. So those are the best problems that you could solve. You definitely want to go that way. So with that, we were feeling pretty good about what we had, And we decided to go ahead and try and get this out into production. And really, again, since my manager and the other managers, since they're, .NET and Java, they were like, hey, is this going to work? Like, it's not an annotation. Yes, it is going to work. And it did work. But like we were able to put that in as a plug for our REST API and then kind of forget about it and just test it the one time, we did have to keep worrying about it anytime that we use a gen server to hit the database. And yes, we know that using Ecto in a gen server is an anti-pattern. Gen servers are for managing state and doing asynchronous processing on that state. But in this case, we had a really strong business case for why we needed to do this. We needed to create that line item in the reports, so then that way customers would be able to say, hey, these were all of our anomalies, so that way they can report that to any government entities that they are working with. And that's ultimately why we went in that direction. And real quick before going to the next lesson learned, like I mentioned earlier, like we were a team of 3. We're a very small team. We started building this service from scratch, from first commit, without knowing that this requirement was coming in until like halfway through, got this worked in to the first customer demo within 3 sprints. So our product team was pretty happy. They were surprised that we were able to move that quickly. All of you know that Elixir gives you superpowers, and you're able to just be really productive. But the lesson here is that everyone needs to be aligned on your team. While we were working on this, we spent a lot of time pairing. We also just spent a lot of time in Slack calls, even if we weren't pairing, just so that way it would be really easy to ask someone to take a look at something, bounce an idea off of somebody. We really tried to over-communicate, and it really paid off because our product team noticed that we were basically hot swappable. Everybody had complete ownership of the code base, so they could just pull one of us at random, bring us into a meeting. They knew that they were going to get a consistent explanation of what was going on because we all knew the system. We all had the same knowledge. It's not like if you watch Silicon Valley, where Guilfoyle and Dinesh, they come to the realization that they both know 98% of the system, but they don't find out till the end that they know the same 98% of the system. Everyone on the project had complete, full context. I am like 10 minutes ahead of every other run that I've done. But yeah, let's go into what would we do different? If we had to start over again today, what would we do? And really what has changed since this was delivered is that Supabase has come out with Supervisor. This is a proxy that's built in Elixir that gives you like a connection pool of millions of connections. Because of this, since you're connecting to the same server, you can go back to using prefixes. Again, I haven't used them, but it didn't look too terribly bad. But since it is highly configurable, it does make it easier to enable a bring your own database scenario, which we've also had further customers ask us for. I personally haven't used Supervisor, but I know Anthony at Sequin has, and they're here in the audience today. So if you have questions about it, definitely talk to them. They're doing some really cool stuff with Postgres, so they will have lots of information for you on that. So with that, let's cover up what we learned. And, you just got to get in, you just got to get something done. Working software is always more valuable than a perfect plan. No amount of planning is ever going to be more valuable than something that works that someone can put their hands on. Again, you can't really take stuff for granted. You do have to maintain your own connection pools now. You do have to write your own custom mix tasks. The good news is that once you have the mix tasks in place, you really don't have to touch them again. And you only have to touch the connection pools again if you start like doing something weird, or if you need to change strategies or something like that. So it's not too terribly bad. Again, like, we know that we like to solve interesting problems, but the intersection of interesting problems and valuable problems to solve, it's not a complete overlap. So you have to default to valuable problems to solve and solving those in a valuable way. Again, a lot of this feels kind of obvious. Hopefully this is a lot of reinforcement of your own knowledge. Again, obvious things aren't obvious. Common knowledge isn't common. You know, in hindsight, once you get in, play around with it, get your hands dirty, you're gonna learn some new things. And especially since we didn't find a ton of documentation on this, we knew that we were going to learn a lot. We were going to uncover some sharp edges, and came out on the other side. Unlike Leroy Jenkins, we survived. We were able to ship. Everything is out in production. We haven't touched it in a couple of months, and everything's fine. It really couldn't be better. And then the last thing here, again, I'm going to harp on team alignment is crucial to success. You want to make sure that you're communicating, but not just communicating, you're effectively over-communicating so that everyone is on the same page. If everyone on your team cannot explain it in the same way, or close to the same way, that's kind of a problem. You need to make sure that everybody can do that, so that way you can have good success. So that's all that I've got. Thankfully, the slides went out right at the very end. So that's it. If you have any questions, definitely come and find me at the conference. I'd love to talk with you. Make a personal connection doing that as well. Thanks, everybody.